Hi guys, so in this video I want to introduce the idea of a logarithm and we're going to be focusing on a base of 10. So first of all, let's just think about powers of 10. So when we talk about base 10, that means we've got 10 as a base and we're raising it to a power. So we know that, okay, if we've got 10 squared, that's 100, 10 cubed, that's 1,000, 10 to the power of 1 is just 10. 10 to the power of 0 is 1. And if we have something like 10 to the power of negative 2, that's 0.01. So we know how to get from a power of 10 to the answer. Well, a logarithm is really about going back the other way. So a logarithm allows us to go from this number here back to the power of 10 that is required to get that number. Okay, so I'm just going to put up the definition of a logarithm on the screen now. So the definition of a logarithm in base 10 is it's the number, it's the power that we would need to raise 10 to in order to get the number that we're interested in. So let's just go through a few examples based on what I've got on the screen now. So for example, the log of 1,000 is equal to 3. And that's because of what we did over here. The log of 1,000 is that power there, it's the 3. Similarly, the log of 0.01 is negative 2. Or we could also say, the log of 1 would be 0, which is an important result. Or the log of 10 is going to be 1. So these are all the results based on the fact that if we want to get the number 10, we need to raise 10 to the power of 1. So there's two key rules that come from this. And so we can say that the log of 10 to the power of x, whatever x might be, is just going to give us x. And if we kind of reverse that, 10 to the power of log x is also equal to x. So one way of thinking about this is, you know how like times and divide are opposites and plus and minus are opposites? Well, log and 10 to the power of are opposites. So if we take a log of 10 to the power of, we just get the value that's in the power. Reverse of that is if that we take 10 to the power of a log, we get this value that we were taking the log of. So they kind of cancel each other out. So those two rules there are really important, and you should write those down. So what we've just looked at there are some really simple examples that all involve bases of 10. The really cool thing about logs is that it actually works for any number. So we can do, for example, the log of 34. Now, I can't do that in my head, I don't know about you, but if you get onto your calculator and actually use the button that says log on it, so if you type log 34 equals, it'll tell you, well, it should hopefully tell you the answer is about 1.53. Now, if you were in the olden days, you would have to look that up in a table in the back of your maths book, but luckily you've got a calculator that'll do that for you. And what that actually tells us is that 34 is equal to 10 to the power of 1.53. So we can take any number here and turn it into a power of 10. One really important thing, though, that I'll finish on is that you can't take the log of a negative number or 0. So that's worth writing down as well. The reason for that is that if you think about it, 10 to the power of anything will never give us 0. We're always going to get a positive number. So we can't take the log of 0 because 10 to the power of nothing will give us 0. There's no possible answer. And same for negative numbers. There's no way that we can do 10 to the power of something and end up with a negative answer. So we can't take the logs of negatives or 0. And that's just a really important point to note. So one last thing is I'm just going to show you how to take some logs of sort of different values. So these examples will help you with the questions that you do in the book. So for example, if you have something like the log of 10 to the power n divided by 10, if we can get this into a base of 10, we can use our log rule that we just wrote down earlier to simplify that down. So using our index laws, 10 to the power n over 10, well, that's actually got a 1 on it. So that can be rewritten as 10 to the power n take 1. And now if we take the log of that, the answer is just going to be n take 1, because that's the power of 10 in this case. Another example that I just want to go through, if we have log of, say, the cube root of 10, remember from our log rule, our index laws, that the cube root, so that's like the third root of 10, is actually the same as having an index of 1 over 3. So in this case, you can rewrite it like this, and so the answer would be a third. Note that the answer isn't 10 to the power of a third. We have to take the log, which means that we're talking about the power that we're raising 10 to in order to get this value. And so in this case, that's a third. And we can combine all of these things in sort of quite complex ways. Like, for example, if we had 1,000 over the square root of 10, it's just the square root, that's the same as the log of 10 to the power 3 over 10 to the power of a half. And that's the same as the log of, if we use our index laws, it's going to be 3 minus a half, which is 2.5, or 5 over 2. And so now that we've simplified it to the simplest possible power of 10, the answer is going to be 5 over 2, because that is the power of 10 that we're talking about. So all I've been doing here is just using this really important rule here, that if you've got the log of 10 to some power, then the answer is just that power. Okay, hope that helps, and thanks for watching.